Today we're going to talk about more polynomial division, continue the section 4.1 from Friday. Again, it's more, like it says on the screen, more division. So that's our objective, is to divide polynomials using synthetic division. So it's going to be a new kind of division, but still kind of the same goal as before, as we learned on Friday. So from Friday, the example was this. Divide that long polynomial by the binomial x plus 3. And from Friday, we know that we have to, when we're putting this in, we have to include all the factors, all the degrees of x. So I need a plus 0 x to the fourth. There's the 30x to the third, plus 0x squared minus 50x minus 2. And again, then we divide this by x plus 3, and then we go through the process. What times x gives me 4x to the fifth, that is of course 4x to the fourth. Distribute, 4x to the fifth. Distribute the 4x to the fourth to the 3, plus 12x to the fourth. Change the sign, make this negative, make this negative, and so on, and we're off. Negative 12x to the fourth, bring down the negative 30x to the third, and so on. So we can go through that whole thing. We're not going to, because that's what we're going to learn today, is something new called synthetic division. So again, that not too bad, takes a while, but on something long like this, but as a whole, the same process as just regular long division. So like I mentioned, we're going to get into what we call synthetic division today. And here is the process for synthetic division. Again, synthetic division you'll find goes a lot quicker, and hopefully is easier in the long run for us. So again, still dividing, the same process. So I'll go from here, and I'll be back and forth between this slide and let me get this slide to show up. There we go. This next slide, which is the same problem as the initial one. So again, back and forth between these two. First, it says arrange the coefficients of p of x in order from the descending powers of x. So we're looking at just the coefficients of the polynomial. We don't want the whole thing. So the coefficients of this, including placeholders. So the coefficients are going to be 4, 0 for a 0x to the fourth, negative 30, 0 for 0x squared, negative 50, and negative 2. There are all the coefficients of p of x, including all the powers that aren't there in the problem of that polynomial. After writing the divisor in the form x minus r, use r to generate the second row and the third rows of the numbers. What that means is we need to write the form in x minus r. So we have this binomial, two terms. I don't want the whole binomial because again we've gotten rid of all of the variables from that polynomial. So I want to take this binomial and solve for x. So I'll do that up here. X plus 3 equals 0. X equals negative 3. So I'm going to take that negative 3 and put it down here next to the polynomial coefficients that I've already written. I'm going to draw a straight line all the way across, and then I'm going to bring down the first term. So again, back to this slide right here, bring down the first coefficient of the dividend, and then multiply it by r. So again, we've solved for r. Now we're going to multiply. So back here, I'm going to bring this down. There's my 4. And now I'm going to multiply. Below this line that I've drawn, I'm going to multiply. 3 times 4, of course, is 12. I'm going to put that, whatever that product is, above the line. So multiply below, put the product above. After I put the product above, add the product to the third coefficient of the dividend. And then repeat the process until we get there. So below the line, I'm going to multiply. 3 times 4 was 12. Above the line, I'm going to add. 0 plus 12 is 12. I'm going to multiply again. 3 times 12 is 36. Multiply below the line. Add above the line. Negative 30 plus 36 is positive 6. Multiply below the line. 3 times 6 is 18. Add above the line. 18 and 0, of course, is just 18. Multiply below. 3 times 18 is positive 54. Negative 50 and 54, add those, add above the line, I get a positive 4. Go ahead and multiply. 3 times 4 is 12. Negative 2 plus 12 is 10. This last number, whatever I get, whether it be a 10, 50, or 0, this is the remainder. And again, that's what it says back on this slide right here. The last number to the right in the third row of numbers is the remainder. So my final answer now. So I can look back at the original polynomial. This is a degree of 5. I'm always going to go to 1 degree less. So my final answer to this problem would be 4x to the 4th plus 12x to the 3rd plus 6x squared plus 18x plus 4. And again, this is my remainder. So then I'm going to add that plus 10 all over the divisor, x plus 3. There's my answer to this polynomial, or to this division problem. The second question, is the divisor a factor of the polynomial? And we all know, again, from Friday, since I have a remainder, the remainder is 10. Since I have a remainder, this is not a factor. So let's move on to another example or two. It's the same type of thing. I have my polynomial. I'm dividing it by a binomial there. So again, I'm going to take the coefficients, including all the exponents of all the powers of x. So just the coefficients, 3, negative 11, 0 for 0x squared, negative 18, and 8. I would set this equal to 0 and solve. So like we just did, x minus 4 equals 0, x equals 4. So I'm going to take that. That's what I want. I want the 4. I don't want the x equals. I just want the 4. Draw a line. Let's try that again. There we go, a little better. And now we'll start. So start by bringing down the first term. And again, here we go, multiplying below the line, adding above the line. 4 times 3 is 12. Negative 11 and 12 is 1. 4 times 1 is 4. Add above, 4 and 0 is 4. 4 times 4 is 16. I get a negative 2. 4 times negative 2 is negative 8. I add above. That's my last term. That's my remainder. So my remainder is 0. So my final answer to this problem, again, I always want to go 1 power less. This is a 3x to the 4th. So my answer is going to start with 3x to the 3rd plus x squared plus 4x minus 2. Since my remainder is 0, I don't need to include it in my problem. It's just 0. And then going back up here to the second question, is the divisor a factor of the polynomial? Because the remainder is 0, yes, it's a factor. Good, moving on. So one other thing that's closely related to synthetic division is the remainder theorem. So if r is the remainder after dividing the polynomial p of x by x minus r, then p of r equals r. Again, as with a lot of theorems, a little wordy and can be confusing at the same time. So let's get into a quick example, and this will hopefully clear some things up. So if we have this right here, find p of negative 3 directly. So we've just got done going over this in our last chapter 3 on functions and things like that. So this will just be kind of a continuation directly. So p of negative 3, this tells me I'm going to plug in negative 3 for all the x values of that polynomial. So p of negative 3 equals 4 times negative 3 to the 3rd plus 10 times negative 3 to, I'm sorry, that's negative 3 to the 4th originally. Negative 3 to the 3rd there, plus 19 times negative 3, plus 5. So just like before, again, when we get a bigger exponents here, this can take a little bit of time. So p of negative 3 equals 4. Negative 3 to the 4th is 81, plus 10. Negative 3 to the 3rd is negative 27, plus 19 times 3 is, or no, I'm sorry, 19 times negative 3, I'm going to get rid of this positive sign here, is negative 57, plus 5. Going back one more time, 4 times 81, so p of negative 3, 4 times 81 equals 324, minus 270 minus 57 plus 5. And then one last time, again, combining all like terms here, just adding and subtracting. So I have 324 minus 270, which is, I get 54 minus 57 plus 5. P of negative 3 one more time. 54 minus 57 is negative 3 plus 5. So P of negative 3 equals negative 2. I'm sorry, positive 2, not negative 2. Positive 2. So again, when we get bigger exponents, that can take a little bit of time. So what that remainder theorem tells us is, again, let's try to go through it a little quicker. So if we use synthetic division, we're going to look for the remainder. So I'm going to set this up using negative 3. So again, I want the coefficients here, all the coefficients of x. I want 4, 10, 0 for x squared, I need a placeholder, 19, and 5. I'm going to divide by negative 3. So again, set up my line, bring down the first term. So I get a 4 here. Negative 3 times 4 is negative 12. Add above, negative 2. Multiply below, negative 3 times negative 2 is positive 6. Add above, 6. Negative 3 times 6 is negative 18. Add above, positive 1. Negative 3 times 1 is negative 3. Multiply below. Add above, negative 3 and 5 is a positive 2. Comparing that to P of negative 3, down here we got P of negative 3 equals a positive 2. Over here, when we evaluated with synthetic division, we got a remainder of 2. So that tells me, again, with the remainder theorem, that my answer will be P of negative 3 equals 2. So the same process, sometimes I think synthetic division goes a little quicker because you don't have to worry about multiplying, taking out to exponents that are cubed and raised to the 4th power and so on. So that wraps up our lesson on synthetic division. And then go ahead and get started on the homework.